All right, this is Honors Algebra 2 Pre-Calculus. We are doing our second video in curve fitting with quadratic models. This is using a calculator. So when you have more than 3 points, it is likely that it will not make a perfect quadratic curve unless the teacher or book specifically chose them in such a way that it would, like you saw in the previous examples in the last video where I clearly chose some tables that I made quadratic, right? So you're going to use a quadratic regression, which is essentially a best fit parabola. As with best fit lines, there's an R value in them to determine how strong the correlation is. These curves have an R squared that tell you the same thing. Closer to 1 means a better match for the data. Closer to 0 means a worse match. So let's go ahead and walk through how we're going to do this. I'm going to put the steps here, but I'm going to walk you through 2 problems doing this. So we're going to enter our data, we're going to calculate the regression, and we're going to write the results. So let's go ahead and walk through 2 examples doing this. So example 3, refer to the pattern of dots below in which each set of dots except the first is formed by adding a bottom row containing one more dot than the previous one, right? So 1 dot, right, first triangle, right, 3 dots in the second triangle when n is 2, 6 dots, right, 10 dots. And it's worth noting, so these numbers are actually called, so these are triangular numbers. So 1, 3, 6, 10, 15. They're triangular numbers, which is a good thing if you're a Quiz Bowl player to just know because it comes up, right? So you can keep going and so on. So explain why a quadratic model is suitable relating the number of dots, D to the triangle. Okay, so if we were to look at this the same way that we looked at a table before, right? So if we're talking about A, if we looked at this like it was a table, the number of dots would be my, or the number 1 would be my, that's the number of rows would be my X essentially, and the number of dots would be my Y, right? So we have 2 and 3, 3 rows, 6 dots, 4 rows, 10 dots, 5 rows, 15 dots, and so on, right? So if we were to look at this data, you can see that your change in n, which in this case is your x, is just a +1, right? But here, we can see that what's happening is I add 2, I add 3, I add 4, I add 5. Oh, look, my second differences are constant, right? This is definitely quadratic, right? So my second differences are constant. That's what tells me that this is quadratic, right? So we're going to find a quadratic model for this. Honestly, because this is exactly quadratic, like this isn't just a model, this is directly quadratic, you could cheat and do it the same way we did before, but I'm going to walk you through how you could do it using a quadratic regression, because sometimes you're not going to have data that is perfectly quadratic. And what we're going to notice when I put this data in is that your R value, or your R squared value rather, will actually be 1 because this is quadratic. So there's a couple different ways to do this. I'm going to go ahead and put this in a calculator. Some of you might be able to see this by visual observation, like you might be able to figure out what's happening, but we're going to go ahead and put this in a calculator. So I'm going to go to Stat, I'm going to go to Edit, and in my list 1, I'm going to put my x values, which in this case are 1, 2, 3, 4, and 5, right? And in my list 2, I'm going to put the number of dots, which is 1 dot, 3 dots, 6 dots. Oh, sorry, my bad, I missed. 6 dots, 10 dots, and 15 dots. And I'm going to double check that they line up. Cool. All right, I'm going to quit out of that. Now, when I want to calculate a quadratic regression, I'm going to go to Stat and over to Calculate, and I'm going to pick Quadreg 5. Now, notice that the default is list 1 and list 2. Some of your calculators don't actually show this setup. They just say Quadreg. That's fine. The default will always be that list 1 is your inputs and list 2 is your outputs unless you change them, right? So if you're using L3 and L4 for some reason, you need to change that accordingly. You can see that the L numbers, you'd press second and then the number. So if you needed like L3, you'd press second and then 3, which would give you L3. So I'm going to go ahead and calculate, and it's going to give me that this is exactly quadratic. The way I know it's exactly quadratic is because the R squared is 1. So I do my quadratic regression. I get this, which we're going to drag over here in a second, right? So then my answer to B, right, my answer to B is going to be D, because that was my Y in this case, right, is 0.5. Oh, I don't quite know how that happened. So my answer to B is going to be that my D is 0.5 n squared plus 0.5 n plus 0, but I don't have to write it. Notice that what this tells me is that this is exactly quadratic. It's not a model, but we already knew that. We already knew that because we did our little check to see if quadratic was a good fit, and sure enough, it showed us that it is exactly quadratic, right? So this is my B, and then C says predict the number of dots in a triangle with 10 dots on each side, right? Oh, sorry, n wasn't the number of rows, n was the number of dots on each side. So this is 2 dots on the side, and this is, so they're saying what happens when you plug in, so d of 10, right? And you can use your calculator to do this, or you can recognize that you can probably do half of 100 and half of a 10, right? And you should get that there are 55 dots. Cool. So again, if you don't, oh, side note, if you don't have this r squared, right, remember that if you don't have this from when we did lines of best fit, which is a possibility, what you're going to do to turn that on, right, so if you have no r squared value, the way you're going to do that, and I'm going to walk you through it now, if you already have that, you can ignore me, is you want to go to catalog, which is right above the 0, so second catalog, and then you want to press the letter D, because what you want is diagnostics on. So you're going to jump down to D, right? And you're going to go to diagnostics on. You're going to pick it, and then you're going to hit enter to run it, right? I accidentally hit enter twice, so you can ignore me. All right, so, sorry, second quit. All right, cool. So that'll turn your r squared on. All right, so now this set is probably not an exact quadratic model, right? So this one you're going to get something, so see how they say models? There's a good chance that when you enter this data, right, you're going to enter this in your L1 and this in your L2, that you're going to get an r value that is not perfectly 1. So go ahead and pause me and do this on your own. I'm going to go back to stat and go ahead and type this data in, stat, and then edit, right? If you want to clear out a list, go up to the top and hit clear. Do not hit delete. You don't want to delete the list. You want the list to stay there. You just want to empty the terms. So 10, 20, 30, 40. It's very nice of them to be so predictable. 50, 60, and 70, right? And then in my L2, I have a 12.5 feet, right, and a 36 feet. It's not worth doing the 0.0. 69.5 feet, 114 feet, 169.5 feet, 249 feet, and a 325.5 feet. Enter. And now they line up. We're all good. I check my numbers. So then here's the nice thing. I actually just did a quadratic regression. If I do second enter, it should, oh, sorry, I did diagnostics on. I forgot. Never mind. So stat, over to calc. I want quad reg, which is 5. And then it does it for me. Boom. All right, so I entered my data, right? There's not much that I can do that I have to do by hand. I entered my data, right? So here's my quadratic regression. My job is to write the equation, right? So my equation is going to be y, and I'm going to go ahead and say approximately because I'm going to round. I'm going to go to 3 places, right? Sorry, 3 places after the decimal. So 0.06. You could use 1 or 2, I don't care which, x squared plus 0.308x plus 4, right? You can also use that entire number. Now, interesting side note, if your calculator does the same stuff that I did, so let's hit second enter, do this again. Okay, oh, sorry, it's going to make me go the other way. Hold on, program, not program, stat, calc, 5. Okay, you can actually store the regression equation if you want, right? If you go to vars and over to yvars and function, I'm going to pick y1. So now what's going to happen is when I calculate this, it's going to do it for me and put it in my y1. Boom. So then it's even easier to use it because then what I can do, right, is I can either go to trace and just plug in 25, which is fine, or I can go to second table set and I can start at 25. So if I then go to table, which is second graph, there's my answer. So y of 25 is approximately 50.17, either 5 or 6, depending on if you round or truncate, and it is feet. So again, notice that if your calculator has that option, you can store, so if your calculator didn't have that option, you'd have to type in the value, and that's fine. Either one's an okay way to do it. All right, that is it for 5.7.